Antiderivatives mean to undo the derivative or go backwards. Let's figure out how that works in conjunction with the power rule. The power rule is going forward. If we take the derivative of x to the n, we end up with x to the n minus 1. Let's think about what happens if we go backwards. To do that, let's make a table. So let's write capital F of x on this side, the derivative capital F prime of x, which will be little f of x on the other side. And so let's take different functions for capital F of x and see what we get over here. Well, obviously, if we just take a constant function like 1, the derivative is 0. If we take a simple function like x, well, its slope is always 1, so the derivative is 1. If we take x squared, we can apply this rule. N is 2, so it's 2 times x to the 1, and we get 2x, of course. For x cubed, again, we apply this rule, we get 3x squared. For x to the 4th, we apply this rule, and we get 4x cubed. What we'd like to do is now go backwards. That is, for antiderivatives, we want to start with this column right here and go back and recover this column. So let's make another table to see how that works. So now we're going to put little f of x in this column, and we're going to try to figure out how to go backwards to get the antiderivative. And so if we start with 0, well, we would go backwards and we would get a 1. But there's other functions whose derivative is 0. Can we think of other functions whose derivative is 0? Well, any constant is derivative 0. So the most general antiderivative is a constant, because the derivative of any constant, just a horizontal line, slope 0. That's the most general function that's whose derivative is 0. So that's the general antiderivative. If we have 1, well, certainly x is one function whose derivative is 1, but x plus a constant, all those functions too, for any constant, also the derivative is 1 because the derivative of a constant is 0. So the most general antiderivative here is x plus a constant. So now let's think about the antiderivative of x. Well, we don't have a 2x, we have an x. But since 2 is just a constant, we could divide by it. And we can say the most general antiderivative is x squared over 2 plus a constant. That is, if we differentiated x squared over 2, we would end up with x over here. So if we differentiate x squared over 2 plus a constant, we end up with x, and this is the most general antiderivative. If we have x squared, again, all we have to do is divide 2 by 3, because 3 is a constant. We'll have x cubed over 3, again, plus a constant. Here we have x cubed, divide 2 by the 4, x to the 4th over 4 plus a constant will be the general antiderivative. We can see a very nice pattern here. You take that 2, if we want to find the antiderivative of x squared, take that 2, add 1 to it, get 3, and then divide by that 3 to get the general antiderivative. And that tells us a formula that will undo the power rule. So we have a formula. If f of x is equal to x to the n, then the general antiderivative is going to be capital F of x, where we take the exponent n, add 1, and divide by n plus 1. That's what we did in all these cases. Of course, we have to add on c. Notice that won't work if n is equal to minus 1, because then we'll be dividing by 0. N equals minus 1 will be a special case that we'll treat later on. But for now, this is a very nice formula because it tells us how to take antiderivatives of just about any monomial function, anything that's x to a power. We can use this rule to find the antiderivative. You need to remember this rule.